All right, here's our game plan. You guys did this quiz yesterday. Most people made little tiny mistakes. So what I want to do is go over the quiz and show you how to do the problem. You're going to follow along as I go over this quiz, and you're going to see your mistakes. You're going to fix your mistakes, and then you're going to take another quiz, right? So let's look at this problem. It says 0.2 moles of H2, 0.2 moles of I2, and 0.2 moles of HI were placed in a 1 liter flask and allowed to reach equilibrium. The KEQ value of the reaction at 25 degrees Celsius is 49.5, and we need to determine the equilibrium concentrations of all substances. So, to do that, we do our rice table. I've got my reaction written, and here I did make a mistake. Many of you saw this, and so this is a reversible reaction. It does go both ways. Now that we have our reaction written, the next line we write our initial condition. So we had 0.2 moles of everything in a 1 liter flask. So by definition, those are 0.2 molar. And this was one of the mistakes that I saw, was some people wanted to put 0 here. In this one, you're told that we actually started with some of the product. So we do have to note that initially we had 0.2 moles of H2I in that 1 liter flask, so that's 0.2 molar. The change, so we lose from the reactant side, we gain on the product side, and we don't just gain X, we gain 2X, right? That coefficient. And so we don't know how much we have at equilibrium. In this case, we have to use X as that placeholder. So each of these is going to be 0.2 minus X amount, 0.2 minus X amount, and this one's going to be 0.2 plus 2X amount, right? So those are my equilibrium amounts. Okay, we should write our KEQ expression. So for this reaction, KEQ is going to equal the concentration of HI squared, because the coefficient in front of that is 2. That was another common mistake. I saw a lot of people forgot to put that square there, divided by concentration of I2 times H2. And I guess it doesn't really matter what order you put those, as long as you have the reactant on the bottom, right? So here's my KEQ expression. Now we're going to substitute. So let's substitute. We know KEQ is 49.5. This is the amount of the concentration of hydrogen. So I'm going to do 0.2 plus 2x. We'll go ahead and put that in parentheses, and that's squared. On the bottom, we've got our other two reactants. Now, I can go 0.2 minus x times 0.2 minus x, right? Since those are the same, would you agree that we can go just 0.2 minus x squared? Does that make sense? It does. So, I love it when this happens. This is such a good situation because we have a perfect square on the top and a perfect square on the bottom. When you have that situation, and it doesn't always come up that way, but when you have that situation, you can take the square root of both sides. Ha! undo those perfect squares. So, according to my math, this simplifies now to like 7.03, 7.04 if I'm rounding. And over here, it's going to be 0.2 plus 2x on top. We got rid of that square. And 0.2 minus x on the bottom, right? This is a pretty easy equation to solve. You don't have to do that whole quadratic thing. You just simplify and solve for x. So you can fast forward through this part, but I'll crank through some math right here. Now I got x on both sides. I got to get x's together. So I'm going to go ahead and subtract 0.2, subtract 0.2, add 7.04x, add 7.04x. So I got 1.2 is equal to 9.04x. Divide by 9.04. I'll write it over here. Well, actually I'll write it over here. I got x is equal to, yeah, that's about 0.13. So once you know what x is, then we just plug it back in and find our equilibrium amounts. So 0.2 minus 0.13, I got 0.07 right there, 0.07 right there, and let's say 0.2 times, I got, well, that's a better circle is in another color. Okay. Now, I will say this, if you didn't see this shortcut with taking the squares on each side, you could have gotten a quadratic. And I'll show you what that quadratic was. Just give me 1 second. All right, let's pretend like you didn't see my shortcut where you realize that this could be simplified to a square and then you could do the square root of both sides. That's okay. Let's just work this problem through and see if we end up with a quadratic and solve that quadratic. So I'm going to FOIL this one, and I will not bore you with all of the math. And you guys are good at algebra, so you know how to do this part. You can simplify that to, and I'm going to also rearrange it to put my largest exponent first. So when I FOILed it, I got this x squared minus 0.4x plus 0.04. And then I've got to get x out of the denominator. So I'm going to multiply both sides by that term. And then multiply it over on this side too. This is where you run out of room. Don't worry, we'll rewrite it. I've got to distribute that 49.5, okay? And when you do, you should end up with, I'll rewrite it off here, 49.5 x squared minus, this was 19.8 x plus, this was 1.98. Oh, we got to square this too. So again, that's math that I feel like you could do. That turns out to be 4x squared minus, I think it was 0.8x plus, right? We're almost there. I got to get everything set equal to 0. So what am I going to do? I'm going to combine like terms. Let's see, that's 40. Right? Add 0.8x, that's 20. I mixed up a sign right there, sorry about that. On this side, this was positive, so now I gotta subtract it. So there we go. Here is your quadratic, right? If you did all your math right, and you end up with this quadratic, you solve and find your zeros. There's more than one way to do that. You can use the good old-fashioned negative b plus or minus the square root of b squared minus 4ac divided by 2a. You can do that. You want to see what that looks like? Plug it into your quadratic, right? Negative b, so I took that and just flipped to make it opposite, plus or minus the square root of b squared minus 4ac divided by 2a. And so I got x is equal to, here, 0.133. Actually, I'm just going to keep 2 digits. Or x was equal to 0.32. So here's my 2 values of x that I got. I started with 0.2, so it would be really hard to lose 3.2. So I don't think that value of x is correct. And guess what? This is the same answer I got when I did my shortcut too. So if I plug in x, 0.2 minus 0.13, I got 0.07. And here, 0.2 plus 2x, so same answers as I got before, just didn't use that shortcut. You're going to take another quiz, and good luck. You can do it. You can do it.